reducing agents out there that you might encounter. A very common one, and this was hopefully seen in Organic 1, is this idea of catalytic hydrogenation. We would use this on a alkene in 220A, but we can also do this reaction with the carbonyl group. So we can take a ketone, treat it with hydrogen gas on something like platinum or palladium, and we can reduce the carbonyl group to an alcohol. This is a very efficient reaction. You just cannot use this if you only wanted to reduce the carbonyl group in the presence of an alkene, so it's going to reduce both. The next one is a reaction that we're not going to discuss the mechanism. It's probably quite complicated and it's not fully understood, but you might see it in your reading. It's called the Clemmensen reduction. So we can take a carbonyl group, treat this with zinc and mercury, and it's supposed to say Hg there, in the presence of acid, and then this will actually change the carbonyl group, not to an alcohol, but all the way down to the alkane. And so we're going to see that there's really three ways you can get rid of a carbonyl group. So if you have an aldehyde or a ketone that you want to remove and just replace it with two hydrogens, this is one of the three ways to do it. We'll see the other two coming up in a little while. So this Clemmensen reduction is a good way to get rid of a carbonyl group. And then a good question is, well, why would you actually want to do that? We've seen now there's a lot of reactions we can do with the carbonyl group. So let's say we needed to add these two carbons through a Grignard reaction, but we didn't want the carbonyl group in the end, so we could do a Grignard reaction, oxidize to the carbonyl group, and then just get rid of it with this Clemmensen reduction. So in terms of organic synthesis, that is a useful reaction. And one more reaction here is what's known as this Baeyer-Villiger oxidation or Baeyer-Villiger reaction. And this one looks kind of strange at the outset, is that you can actually take something like this ketone in a 5-membered ring, and in this reaction, turn it into a 6-membered ring. So we've actually expanded the ring. It's like we've added an oxygen here, and we generated here what's known as a cyclic ester, or a lactone is the name for this. This is one of the, I don't expect us to memorize the mechanism of this, but just to cover it very briefly, so that's how it's thought to occur, is this CH3CO3H is a peracid, which is a kind of unusual type of compound. Hopefully in Organic 1, you saw the wonderful reagent of MCPBA, which is also a